So chapter 20, electrochemistry, and Trow puts these quotes at the beginning of each chapter, and I like this one from Michael Faraday back in the 1800s. "One day, sir, you may tax it." And this was his response to Mr. Gladstone, who's the British Chancellor of the Exchequer, who was asking about the practical worth of electricity. Because especially politicians often want to know, well, how's this going to help us, right? What is this good for? And Trow puts this in here to point out that basic research just for knowledge's sake, is very important, and it needs to be funded. We need basic research because we get lots of new discoveries that lead to more practical developments. So, as we all know now, electricity, super valuable, right? Okay, of course.
Are you gonna start the recording?
Okay, so section 1 talks about lightning and about batteries. I think we're all familiar with lightning, but we probably don't understand exactly what's going on with lightning. It's actually electricity, which you probably knew, but how does that come about? It's a very dramatic demonstration of the power of electric current. A battery works on similar principles. The driving force for both is the same, which is that electrons flow away from negative charge and towards positive charge. And that has to do with Coulomb's law that opposite charges attract and like charges repel. So, what happens in a thundercloud that generates lightning? Well, there are violent air currents that cause water droplets to collide with ice particles. And those violent collisions cause electrons to get knocked off of molecules, creating positive charges and negative charges. The positive charges accumulate on ice crystals, which move towards the top of the cloud on rising air currents. The negative charges remain in the bottom of the cloud, and the charge separation will exist, unhappily so, until a method of equalizing it comes about. And this typically happens as a channel of ionized air that develops between these two separated charge masses, and that allows massive amounts of charge to flow through it. And that's what we see as lightning. Most lightning happens within a single cloud, or it can happen between two thunderclouds. But if the cloud gets close enough to the ground, the negative charge at the bottom of the cloud can cause positive charge to accumulate on the ground, and then when a channel of ionized air forms between the ground and the cloud, the charge will flow to the earth. And that's called cloud-to-ground lightning. That's when the lightning strikes things, people or trees or buildings, that sort of thing. Anybody have any questions about lightning? So batteries also deal with separate charges. Batteries composed of two substances that have different affinities for electrons. Those substances are separated, and so one will develop a positive charge, the other develops a negative charge. And the charge separation will remain until a conductive path allows electrons to flow from the negative end to the positive end of the battery. So typically that's done with a metal wire in some sort of a circuit. That allows electrons, as they pass through that wire, to do electrical work flowing to the positive end of the battery. So I guess you could think of it as very, very small scale lightning that we can harness to do good stuff.